In this lesson, we are multiplying polynomials. So we do want to make sure that we know what a polynomial is. A polynomial is just an algebraic expression, which means there's no equal sign, and it's typically terms that are separated by a plus or a minus. So for 4x plus 9, we have the term 4x, we have the term positive 9, and they are being added together. That makes that a polynomial. Poly meaning multiple, so 2 or more, and nomial refers to the number of terms. So in this example, we have 2 terms here and 3 terms here. Now when we're multiplying polynomials, we're going to use something called the box method. Now it's pretty simple. We just create a box using the first polynomial for the rows. So since we have 2 terms here, that means we're going to have 2 rows. And use the second polynomial for the columns. So since we have 3 terms here, that gives us 3 columns. Now you can see where I've already taken our 2 terms here and placed them as the rows on our box. Then I've taken the 3 terms from this polynomial and made them the 3 columns at the top of the box. So we have 2 rows by 3 columns. Now what we're going to do is we're going to multiply within each box. So you can see I have a couple of arrows here. 4x times 2x squared, or 2x to the second power. You're going to multiply those coefficients. So 4x times 2x squared, you're going to multiply 4 times 2 to get 8. And then you're going to multiply x times x squared. And when you multiply your variables, you're going to add those exponents. So that's like x to the first power times x to the second power. So we're adding 1 and 2 to give us x to the third power. So again, 4x squared times 2x to the second power, 4x times 2x squared, or 2x to the second power, gives us 8x to the third power. Now we're going to continue that. We're going to multiply 4x times negative 5x, and that's going to go in this box. So 4 times negative 5 is negative 20. X times x is x to the second power, or x squared. Then we have 4x times positive 3. So we're going to multiply 4 times 3, which gives us 12, and then we still have to multiply by that x. Now moving down to the second row, we have a positive 9. So positive 9 times 2x squared. So we're going to multiply 9 times 2, which gives us 18. And then because we had to multiply by the x squared here, we're going to bring down that x squared. So 9 times 2x squared gives us 18x squared. Now we're going to go to 9 times negative 5x to the first power, or just negative 5x. So 9 times negative 5 is negative 45. And again, we have to multiply by the x because that was negative 5x. And finally, in our last box, we're going to multiply positive 9 times positive 3, which is just a positive 27. So typically what I'll do is just double check my multiplication. And then anywhere that I have just a positive number, I make sure to put a plus in front of it. And I only do that because the next step requires us to combine any like terms. So all of these terms that we have now, we have 1, 2, 3, 4, 5, 6. We have 6 terms. So with those 6 terms, our goal is to now simplify those 6 terms by combining any of them that have the same variable with the same exponent. So we have an 8x to the third power we have x to the second power, we have another x to the second power. So those x to the second power are like terms because they both have the variable x that has the exponent 2. Then we have a 12x and a negative 45x. Since those both have an x just to the first power, those are like terms as well. So you'll notice that typically your like terms are going to be diagonal. And what we can do is we can add those coefficients or combine those terms. So we're going to bring down the 8x to the third power. And then next what we're going to do, I'm going to write this all out to start with, and then I'm going to combine those like terms. So we're going to add or combine the negative 20x squared plus the 18x squared because those are like terms. And then we're going to combine the positive 12x and the negative 45x. And finally we have that plus 27 on the end. So again, our like terms are negative 20x plus 18x, and then 12x and negative 45x. So we can actually write this as 8x to the third power Now we're going to combine negative 20 plus 18 is negative 2x to the second power. Then 12 minus 45, well, 12 minus 45, we need to make sure that we are doing our subtraction correctly there. You can always double check yourself, but if we are subtracting 12 minus 45, we need to make sure that that's going to be a negative number because 45 is larger. And we're going to see what's the difference between 12 and 45. So that's going to be 3, so this is going to be negative 33x. And then we have plus 27. So now you can see I've combined all my like terms. I have an x to the third, I have an x to the second, I have just an x, and then my plain coefficient, that old constant number, goes on the end. So that is our final answer. Now let's just do a few more examples. Example 1. Right, before we get started here, we want to see how big does the box need to be so that we can organize our work. Well, in the first polynomial, we have 2 terms, and in the second polynomial, we have 2 terms, right? 1, 2, 1, 2. So we need to create a 2 by 2 box. That means it needs to be 2 high and 2 wide. Right, so I'm going to create a box, and then I'm going to split it so that it's 2 high and 2 wide. So that gives me a total of 4 individual boxes. Now we're going to write our first polynomial, 3x and positive 2, goes on one side of the box, and then the other polynomial, x plus 4, goes on the top. Now we are simply going to multiply within each box. So 3x times x is going to give us 3x squared, right? Because this is technically like a 1x, and they have exponents of 1 if they're not written. So that's 3 times 1 is 3, x times x, you're going to add 1 plus 1 to get x to the second power. Then we have 3x times 4. So 3 times 4 is positive 12, and we do have to multiply by that x. Then we're going to go down to the second row. So positive 2 times x by itself. So just 2 times x is 2x. Then we have 2 times 4, which gives us positive 8. So again, I'm just going to go back and put some positive signs in there. Now we want to combine any like terms. So I can see that 12x and 2x both just have a plain old x. So those are going to be like terms. So that gives us 3x squared plus 12x plus 2x plus 8. Now again, we're going to combine those like terms that are there in the middle. So that gives us 3x squared plus 14x plus 8. All right, example 2. This time I have two terms by 1, 2, two terms. So again, we need a 2 by 2 box. Right, now I'm going to put 3a and then minus b on the left side, and I'm going to put 2a plus 4b on the top. Now we get to multiply. So 3a times 2a, 3 times 2 is 6, a times a is a to the second power. Now for 3a times 4b, 3 times 4 is 12, positive 12. A times b is just a times b. Now we have negative b times positive 2a. So negative b, that's like a negative 1b. So I'm going to write negative 1b. So when we multiply these, negative 1b times 2a, negative 1 times 2 is negative 2. Then we still have b times a, or a times b, so it's just negative 2ab. Finally, negative b, or negative 1b, times positive 4b. Negative 1 times 4 is negative 4. B times b is b to the second power. Now we want to look for any like terms. Be careful here because a to the second power and b to the second power are not like terms. They have to be the same variable in order to be like terms. 12ab and negative 2ab have the same variables with the same exponents. A to the first power, b to the first power. So those are our like terms here. So that gives us, our final answer is technically 6a squared plus 12ab minus 2ab minus 4b squared. Now our like terms are there in the middle. So that simplifies to 6a squared plus 10ab minus 4b squared. All right, let's look at example 3. Here we have two terms times 1, 2, 3 terms. So this time we're going to have a 2 by 3 box, which we haven't done one of those yet except for that very first example. So we need to make a box that's a little larger this time. It's going to be 2 boxes high and 3 boxes wide. So I'm going to make this one a little long. And we're going to divide it into 2 sections tall. Whoops. So that's 2 sections tall, and then 3 sections on the top. So there's 1, 2, and 3. All right, so 2b plus 1 goes on the left. And then b squared minus 5b plus 4 goes on the top. Notice that since this 5b has a negative in front of it, I keep the negative when I write it in the box. Now we're going to start multiplying. 2b times b squared. So remember 2, that's like 2 times 1 if there's nothing written in front of the b. It's like a 1b. So that's still just 2. And then b times b squared, b to the first power times b to the second power, we're going to add those to get b to the third power. Moving over, 2b times negative 5b. 2 times negative 5 is negative 10. B times b is b squared. 2b times 4. 2 times 4 is 8. And then times b. One times b squared, anything times 1 is just itself, so that's just b squared, and that's a positive. Positive 1 times negative 5b, anything times 1 is just itself, so again, negative 5b. And then in the last box, 1 times 4. Positive 1, positive 4. All right, so now this time we are going to have to make a little more room because we have 6 total terms this time. 1, 2, 3, 4, 5, 6. So we do want to identify any of our like terms. That means if the only variable we have here is b, we want to look at the ones that have the same exponent. So we have a b to the third power, but then we also have b to the second power and negative 10b to the second power. Then we also have 8b and a negative 5b. Those are also like terms because it's just a single b. Okay, if I were to write all 6 of these out, that would be 2b to the third minus 10b squared plus b squared plus 8b minus 5b plus 4. But we are going to simplify by combining like terms. So that's going to give us 2b to the third. Now negative 10b squared plus b squared, that's going to be negative 10 plus 1, which is negative 9b squared. 8b minus 5b, 8 minus 5 is positive 3b plus 4. Now we're going to use multiplying polynomials to help us find area of different shapes. We're only going to focus on rectangles and triangles because that's what we've talked about so far. We know that the area of a rectangle is length times width, and we know the area of a triangle is 1/2 times the base times the height. So let's look at an example. Number 4. This rectangle is x plus 6 meters long and 2x minus 1 meters wide. So we have the length times the width that we need to find. So we're going to have to find what is x plus 6 times 2x minus 1. Well, in order to multiply these, we can create a box and use the box method. This one would be a 2 by 2 box. So I'm going to create a box that is 2 wide and 2 tall. So 1, 2, and 1, 2. Right, I'm going to do x plus 6 on the left, and then 2x minus 1 on the top. And now we multiply. X times 2x is 2x squared. X times negative 1 is negative 1x. 6 times 2x is 12x. And then 6 times negative 1 is minus 6, or negative 6. Now I do want to make sure that we put a positive 12x there. All right, and now we can identify any like terms. So just plain old x's, those are diagonal. So that gives us 2x squared minus 1x plus 12x minus 6, and we are going to combine those like terms. So that's 2x squared. Now negative 1 plus 12 is positive 11x minus 6. So the area of that rectangle would be 2x squared plus 11x minus 6 square inches, or meters in this case, square meters. Okay, let's look at number 5. We are looking for the area of this rectangle. So we have 2x times 3x plus 2. All right, this one is going to be a little bit different just because this is only one term. So we're going to have a 1 by 2 box, which we haven't looked at one of those yet, but it's actually pretty simple. We just need to create our box, which is going to be 1 across and 2 separated spaces. So we are going to put 2x on the left and 3x plus 2 on the top. And then we're just going to multiply like normal. So that's going to be 2x times 3x, which is 6x squared. And then 2x times 2 would be 4x. And that's a positive 4. So this one was pretty simple. It's just going to be 6x squared plus 4x. And there are no like terms to combine here, so that's it. And finally, let's look at a triangle. So here we have this triangle, and we know the area is 1/2 the base times the height. So in this case, we want to make sure that we have the base and the height, and we do. We have the base here, and we have the height here. So we need to calculate 1/2 times the base times the height. Now, I don't particularly like having it written this way, but it's perfectly fine if you do. I typically like to write it with the smaller polynomial first. So it's really the same as 1/2 times 2x times x plus 4. So I only switch those because when I create a box for this, I want it to just be a pretty simple box to draw. So this would be, again, a 1 by 2, a 1 by 2 box here. All right, so we need just 1 tall and we need 2 across. So I'm going to put 2x on the left and then x plus 4 on top. And now we multiply. 2x times x is 2x squared, and 2x times 4 is 8x. Now, that's all we got for the base times the height. Okay, so for the base times the height, we got that that is 2x squared plus 8. So I'm going to make sure that we have are able to keep this organized, okay? So I'm going to move this up a little, And this was like our step 1. We found the base times the height. Okay, so this part here, the base times the height, we got is 2x squared plus 8x. But now we still have to multiply 1/2 times that. I don't want that to look like an x, so I'm going to put a little dot instead. Okay, so remember that we still have to multiply 1/2 times all of this. So 1/2 times both of those, you can create another box, or you can just do 1/2 times 2 and 1/2 times 8. Either way is perfectly fine. So I'm going to create another box so that I can multiply 1/2 times 2x squared and 1/2 times 8x. Okay, so 1/2 times 2x squared, 1/2 times 2 is just 1x squared, and then 1/2 times 8 is 4x. All right, so our full simplified answer is going to be 1x squared, which you don't have to write the 1 in front, so just x squared is fine, plus 4x, and that is it for that one.